Minecraft TNT. Perhaps one of the funniest game mechanics ever introduced to Minecraft for half an hour session of brain-dead fun. But is actually the Minecraft TNT scientifically accurate? Is the volume and the radius of the explosion it creates scientifically accurate? Well, let's talk about that. First, I want to say that the TNT we see in Minecraft is not scientifically accurate. Now, you see, TNT stands for trinitrotoluene, which is a solid that often comes in the form of small yellow stones. Now, the TNT in Minecraft is made out of gunpowder, which is a whole other substance in itself. Gunpowder is a grey or black substance that you can gain by killing a creeper, but in real life, gunpowder is made out of coal, potassium nitrate and sulfur. Although sulfur is not necessary for the gunpowder to work, it just makes it more efficient. There is a problem with gunpowder. You see, gunpowder is a low explosive, meaning it doesn't detonate, it deflagrates. Deflagration is just a fancy word for catching fire, but in this context it means that gunpowder just burns really fast. In order for something to detonate, it will have to burn as well as to create a shockwave in the surrounding area. Although gunpowder doesn't give off a shockwave when it expands, it can still do damage. You see, if we ignite gunpowder in a limited space, like a bottle or something, the explosion or the expansion will be much more violent and happen much quicker, resulting in a ball of gas that can damage the surrounding area. This brings me to the problem with gunpowder. You see, if gunpowder was actual trinitrotoluene, it would have been easy to predict the outcome of the explosion. I am sure there are loads of formulas out there. But because Minecraft TNT is gunpowder and gunpowder is unpredictable and messy, it gets tougher. But before we can do any calculations with real life gunpowder, we need to know some stuff about Minecraft TNT, the stuff we are comparing it to. How much gunpowder are we handling here? Well, if we take a closer look at the texture of the TNT, we see that it is composed of 16 tubes of gunpowder, which have each 4 pixels. On the top of a block we have 256 pixels in total, and 64 pixels with gunpowder. And since we're assuming that the gunpowder goes through the entire bomb, we have here 1/4 of a cubic meter of gunpowder, or 250 liters of gunpowder. Let me just interrupt the flow of the video here to say that is an enormous amount of gunpowder. Like, imagine a carton of milk that you have in your fridge, right? Filled to the brim with gunpowder, that's a lot. Now multiply that by 250. That's like your entire fridge filled to the brim with gunpowder. Anyways, back on topic. Second thing, what are we comparing our results to? How big is actually the diameter of a Minecraft TNT explosion? Or how much volume does it take? The first one is actually quite easy to find out. Just make a hole in the ground, place a TNT and check the radius of the explosion. Easy. I found it to be about 7 blocks or 7 meters. Volume, on the other hand, was a little bit more complicated to measure, but I did it. I ignited 10 TNTs underneath the ground and filled them all using the /fill command. When you use the /fill command, it says in the chat afterwards how many blocks it filled, and I got 1467. Divide that number by 10 and you get that the volume of one Minecraft TNT explosion is 146.7 blocks or 146.7 cubic meters. That is what we are going to compare our final results to. Now over to real gunpowder. When real gunpowder deflagrates, it creates a flame ball that is made out of gas, and it has the same volume whether or not the gunpowder is contained within a limited space, like inside of a bomb or something, or if the gunpowder is out in the open. This flame ball is made out of gas and gas alone, and we need to figure out how much of the explosion is gas and how much it expands to. Now there are 4 stages to an explosion that I would like to inform you about in order for you to understand what I am about to do next. Stage number 1. Everything here is stable. The gunpowder is being contained within the box of TNT, so nothing is really happening. It is not ignited, it is not deflagrating, so nothing is happening. It's quite boring actually, but it's still important. Stage number 2. The chemical reaction is happening and gunpowder has been ignited. The gunpowder has now turned into nitrogen and carbon dioxide and some other stuff, but those aren't really important for us right now because they aren't gases. The carbon dioxide and nitrogen take up a bigger volume when they are outside of the container than inside, thus they put a big pressure on the sides of the container. Third stage. The explosion happens. Carbon dioxide and nitrogen take up a bigger volume now that they are burning, and thus they annihilate the container they are within and releases in a big gas cloud. Fourth stage, everything cools down. The warm carbon dioxide and nitrogen have now cooled down and they are heading towards something called STP, standard temperature pressure, meaning that they have about 0 degrees Celsius if it is 0 degrees Celsius in the atmosphere, and they are under 1 atmospheric pressure. 1 atmospheric pressure, or ATM, surprisingly called that, is about the same pressure you experience when you are outside. 56% of the mass of the explosion are solids, 43% gases, and 1% water. We know that the volume of our gunpowder is 250 liters, and thanks to Wikipedia, we know that the density of gunpowder is 1.7 kilos per liter. This means that we are dealing with 425 kilos of gunpowder and 182.75 kilos of gas. We need to figure out how much gas is being released in a unit called moles, and convert those moles from volume, and after that find out how much that volume expands because of the heat. A mole is actually a number for how many objects we have of something, usually molecules or electrons. That number is exactly 6.022 times 10 to the power of 23. That is 6.022 sextillion objects. Or so say you had a mole of water, for example, or water molecules, that would be 6.022 sextillion water molecules. Or a mole of electrons, that would be 6.022 times 10 to the power of 23 electrons. The amount is always constant. The simplest balanced formula for a chemical equation of a gunpowder explosion says that the outcome is 5 nitrogen molecules and 6 carbon dioxide molecules. In this case we are going to expand that formula, so there will no longer be 5 nitrogen molecules and 6 carbon dioxide molecules. No, 5 moles of nitrogen and 6 moles of carbon dioxide. 1 mole of nitrogen weighs about 28 grams. 1 mole of CO2 weighs about 44 grams. Now, if we say that in our chemical equation, instead of 6 moles of CO2, we replace the moles with the weight of the moles. If we do that, we find out that 11 moles of gunpowder gas would weigh about 404.73 grams. 6 moles of carbon dioxide weighs about 264 grams, while 5 moles of nitrogen weighs 140 grams. We need to take those numbers and divide them by 1% of 404.73 grams. If we do that, we find that carbon dioxide takes up 64.24% of the gas of gunpowder explosion, while nitrogen takes up about 35% of the gas of the gunpowder explosion. Now, if we just take those percentages and turn them into decimals, of course, then multiplied by the original amount or the original weight of the gas that we had coming from our TNT explosion, we have 119 kilograms of CO2 and 63.5 kilograms of nitrogen. Now what we need to do is to turn those kilograms into moles again. We do that by dividing them by how many moles there is per kilo of that substance. So per 1 kilo of carbon dioxide, I forgot to write that up, but never mind that, we have about 0.4401 moles per kilogram and 0.02800134 moles per kilogram in nitrogen. We divide the original amount of gunpowder by that number, and we get that in carbon dioxide we have 279.06 moles of carbon dioxide in our mixture of gunpowder and 2,266.97 moles of nitrogen in our gunpowder mixture. Put those together and we have about 5,000 moles of gas. Now I can imagine you probably are thinking something along the lines of this. Okay, so we have the amount of moles of gas this gunpowder releases, but what has that to do anything to do with anything? Well, ladies and gentlemen, I give you molar volume at STP, 22.4 liters. This chemical law states that the mole of any gas, no matter which type, at standard temperature and pressure, meaning 1 atmospheric pressure and 0 degrees Celsius, will have a volume of 22.4 liters. This is brilliant for us because we can just take our moles and multiply it by 22.4. Then we find out how much volume our gas will have. And if we apply this to our 4,973.03 moles of gas, we find that we have, in the end, 111 cubic meters of gas, or 111,000 liters. That whole ordeal is assuming that the gas is at STP, standard temperature and pressure, 0 degrees Celsius, 1 atmospheric pressure, all of that nonsense. But our gas in the gunpowder explosion isn't 0 degrees Celsius, it is much more. This is where we have to take Charles' law into use. If you just so happen to don't know what Charles' law is, then you can get out! I'm kidding, you can stay. Charles' law states that volume and temperature are connected. Temperature divided by volume equals temperature 2 divided by volume 2, meaning that as the temperature rises, so will the volume, and as the temperature falls, so will also the volume. So let's plug in the numbers, shall we? Well, we start off with a volume of 111 cubic meters and 273 degrees Kelvin. The gas then burns, and it has the temperature of 3050 degrees Kelvin, but we don't know the volume. Solving all of this, solving it for volume 2, we get that the second volume is 1245.28 cubic meters. Whoa! The original Minecraft TNT had a volume of about 146.7 cubic meters, or blocks, which is about 130 blocks/cubic meters, too short for what would be realistic for that amount of gunpowder. The conclusion of the video is that Minecraft TNT is not realistic. Technically, it is impossible to calculate the complete outcome of a gunpowder explosion because, well, okay, I've been lying to you guys. Gunpowder explosions doesn't just happen in a single chemical reaction, it happens in many small, tiny chemical reactions, and those chemical reactions have their own formulas. So it is impossible to calculate the exact outcome, but with my calculation I have come somewhere near the answer. Not exactly the answer, but somewhere near, because exactly the answer would be impossible. Chaos theory, look it up. My sources will as always be linked in the description below so that you can check them out yourself. However, this time it was surprisingly difficult to do research, and thus I had to trust some rather sketchy ones, like online forums and people just saying that they know stuff. It's rather sketchy. Because it was so difficult to find sources for this video, it was also difficult for me to do research on the topic. I spent many days and in all, perhaps like a week or something, just researching this one topic. I even worked myself until I vomited at one point. Yeah, no kidding, that actually happened. So if you would be so kind to I don't know, leave a nice comment or like this video or something. That would mean the world to me, but no pressure. Thanks for watching and have a blast. And the element of the month is europium. Europium is a hard metal with a silvery color. It is very reactive and easily oxidizes in both water and the air. Don't forget to vote for your favorite element in the monthly element contest down in the comment section. Who knows, maybe your favorite element will be the next element of the month. You know, I actually tested Minecraft TNT on different substances after the script was done, and it turned out that TNT was more effective on dirt and sandstone than on ordinary stone. So there's a bit of a flaw in the experiment there. But it looked sort of like the gas expansion was equally as big as the crater it created in sandstone. So I just went with sandstone. Also, that would never happen in real life. Like I don't know how to calculate how a crater is created, but I know that won't happen. Like the gas expansion is not as big as the crater. That's just common logic, common sense. Eat your vegetables.